Hello dear students, this is your Saurin sir, back with electrophilic substitution reaction. Today we'll take one more electrophilic substitution reaction, also known as Friedel-Crafts acylation reaction. You have already come across nitration, sulfonation, halogenation and Friedel-Crafts alkylation reactions of benzene. Today I am going to deal with Friedel-Crafts acylation reaction. The name, the prefix is Friedel-Crafts. If you have gone through the previous episodes of alkylation reaction, you are aware of why it is a Friedel-Crafts acylation reaction. Because of a typical reagent. We talked about that in detail in the previous episode of alkylation, that is anhydrous aluminum chloride. In this reaction, that is Friedel-Crafts acylation reaction, we are going to react benzene again with anhydrous AlCl3 as the catalyst. Let's see. This is your benzene. C6H6 is the molecular formula. We want to perform acylation reaction on benzene, that is in the form of Friedel-Crafts acylation. Now for acylation reaction, the choice of the reagent which is going to react with benzene is very important. The word is acylation. That means we are somewhere near a group named as acetyl group or aceto group. That aceto group can be generated from a very near close compound that is quite similar to the name of the reagent, and that is acetyl chloride. That is one possibility of the compound. You can choose acetyl chloride, you can generate an aceto group. Why aceto group? Because we are on with electrophilic substitution reaction. We have studied earlier, we need an electrophile for the reaction. So from acetyl chloride, you can pluck aceto group. That is one reagent you can have a choice of. There is one more similar line reaction and reagent, and that is your acetic anhydride. That is also one reagent which can give you Friedel-Crafts acylation. Today we are going to talk for both the reagents and we'll study the whole reaction over here. Let's see. First I'll take CH3 COCl, that is acetyl chloride. This is acetyl, ACETYL chloride, CHLORIDE. This is one reagent. We'll talk first regarding this. CH3COCl in presence of anhydrous aluminum chloride, which is going to act as a catalyst, as we have already understood in the previous episode of Friedel-Crafts alkylation. How the mechanism is going to take place, I'll definitely explain you again, don't worry. What happens in this? We have got CH3COCl. I'll write it in the actual form of bonding form, of sharing form. CH3COCl. This is a reagent, acetyl chloride. I'm going to react with AlCl3. So I'll write Al for you and I'll show 1, 2 and 3 valence electrons of Al. As you know, it is of the 13th group element, valence electrons 3. Bonded with 3 chlorine atoms, each from 7th group having 7 valence electrons. So I'll be differentiating the atoms with respect to the dots and the crosses, nothing else, they are only electrons. And you can see the bonding takes place over here. So that is your AlCl3. Now what happens? It is not normal AlCl3. I have highlighted, I have specified many a times in the previous episode as well. That very important part is the word anhydrous. This anhydrous AlCl3 indicates that it is lacking water because it is hygroscopic in nature. It will have a tendency to absorb moisture from the atmosphere. So we are specifying that it is anhydrous AlCl3. Due to that reason, we will just react it with acetyl chloride. Now you know chlorine is more electronegative than carbon, and so chlorine will be pulling away the electron of carbon to which it is shared, and that Cl now with a minus sign will get attracted to Al because it has got one electron extra, 7 plus 1 of carbon, 8, and so it will form a coordinate covalent bond with the aluminium. So now you can see what you are formed with is AlCl4 minus because one chlorine got into the compound, and here you will have CH3 bonded to C and O. The carbon chlorine bond breaks, fine, and as a result you will have COCH3, where on this carbon, please keep the things very clear, on this carbon from which chlorine has left will attain a plus sign. Do you get it? It is CH3CO, it is CH3CO. I have written COCH3 just for simplicity. Okay, this is your aceto group, which we talked about, right, in the starting of the lecture. This is aceto group, and this is your electrophile. So this aceto electrophile is going to participate in the reaction. The mechanism is as we understood for the previous reactions: nitration, sulfonation, halogenation, alkylation. The H bonded to the benzene ring leaves the carbon, any one carbon, and as benzene is rich with pi electron cloud, definitely we will talk regarding pi electron cloud in later episodes, right, above and below the plane of benzene, and due to that this electron deficient group will get attracted on benzene nucleus. So here you can see the carbon of benzene will have plus sign, sorry, minus sign because H has left the carbon, and COCH3 which has got plus sign will be bonded over here with plus sign. So the plus and the minus forms a bond, and now plus and minus gets nullified to give you a compound which is named as, the group is aceto group, fine, and benzene when has one hydrogen less, it is C6H5, it is C6H5, that is known as phenyl, but that phenyl is bonded to a group known as ketone. It's a keto group, and so ketone has a suffix ONE, so the compound is named as acetophenone. This is the name of the compound. Other way around, you can also name it as, this is the methyl group, this part, so you can name it as methyl. This part is phenyl, and this much part is ketone, so you can name it other way as methyl phenyl ketone or acetophenone. You can name either way, acetophenone or methyl phenyl. Acetophenone is based on the whole group aceto group with phenyl ring, so acetophenone, and if you split all the three groups, the phenyl group, the methyl group, the keto group, then it comes to methyl phenyl ketone. This is how the compound is named. Fine. One second. Now what happens? This CO group is already bonded, but the H which left the carbon now has got plus sign. That H with plus combines with Cl minus of AlCl4 minus, and that forms a byproduct, HCl in this case. Got it? Okay. As HCl is formed as a byproduct, what we are left with is AlCl3 because Cl minus is bonded to H plus, and so this AlCl3 acts as a catalyst. So that is the whole mechanism of the reaction, quite similar to alkylation reaction, and overall reaction occurs, as I said earlier, at 80 degree, which was the same for alkylation reaction of benzene, or you can convert it to Kelvin, so accordingly you can add it to 273, and that becomes 353 Kelvin temperature. So either 80 degree or 353 Kelvin, it's one and the same. See, many times you have to be practically smart. To remember 353, it becomes a little bit difficult. So what you need to do, you have to make the thing simpler. 80 degrees is easy to remember, 353 you are a little bit confused sometimes. So remember this, add 273 to it and you get your Kelvin temperature, right? So this is some technique, some tricks, and that is why you are here with me, fine? So that is the reason, right? Now I said this reaction occurs with two reagents. One was acetyl chloride, I just took it over here. Now other reagent I am going to take with some substitutions I will do there itself, huh? Just concentrate over there. Instead of acetyl chloride, I'll just substitute this Cl with this part, that's all, nothing else. Now what is that? I'll explain you, don't worry. First I'll give the name to the compound. The name of the compound is acetic anhydride. Acetic anhydride, CH3CO twice and O. What is the constitution? Just I'll show you over here. Just concentrate. See, we have got CH3, CO, again CH3, CO. Find two aceto groups. And you know carbon has got 4 valencies, so both the carbon atoms have got 1 valency yet to be formed. Bonded with oxygen, and you know oxygen has tendency to form a double bond, so it forms 2 bonds, one each with both the carbon atoms. This is that constitution over here. This compound is known as acetic anhydride. This compound is derived from acetic acid. When 2 moles of acetic acid are heated at a very high temperature in presence of aluminum phosphate, the water molecules get dehydrated from the compound and the compound formed is acetic anhydride. Fine, so that is there, and that is why the name is also derived from acetic acid without water, and so it is named as acetic anhydride. This reagent can participate in a similar fashion. Everything is same, only the reagent has variated. Earlier it was acetyl chloride, now we have taken acetic anhydride. Rest things remain the same. Only a minor change, and that was CH3CO twice O instead of CH3CO Cl. And the constitution also I have shown you over here. Now what happens? Same concept. Instead of Cl, I am going to write over here a little change, that is CH3CO, and that what I have shown over here I am going to write the same thing, simply COCH3. This is the same thing, fine, and that again breaks from here as Cl in the form of minus got detached from the compound. Now here you have CH3COO with minus, and this C is with 1 plus, because O is more electronegative than carbon. It pulls away the electron of carbon towards it, and as a result this CH3COO minus will form a huge compound with AlCl3, temporary basis. It is also unstable, fine. But what we are concerned with is CH3CO plus, and that CH3CO plus attacks the benzene nucleus as earlier understanding, and same product will be formed. Not only that, what happens, the H which leaves the benzene ring combines with this part CH3COO minus, and H is with plus. So if you take acetic anhydride, the byproduct will not be HCl, but it will be your CH3COOH. That will be your byproduct. Fine. If you take acetyl chloride HCl, if you take acetic anhydride, it will be CH3COOH byproduct, and again you will get AlCl3 back, and that will act as a catalyst. Simple reaction, only a change, minor change of the reagent. Choice of reagent, it's up to you. In the laboratory you can either go with acetyl chloride or acetic anhydride. The product will remain the same. Is it clear? Now one more very important point. In every reactions, whether it was nitration, sulfonation, halogenation, alkylation, fine, any reaction, we had always taken 2 parts. Fine. In acetylation reaction, further acylation reaction is not possible. So we won't have a second part for this lecture. Fine, you will end up here itself, because the group COCH3 group is a very bulky group on carbon atom, and as it exists, if same reaction with the same reagents is repeated for second time, the compound will be highly unstable and it cannot exist at all, and so the further reaction in acylation, that is Friedel-Crafts acylation, is not possible. It is only possible for single step, either with acetic anhydride or earlier we saw acetyl chloride. So these are only the two reagents and a single step reaction of benzene. So this is the whole scenario of electrophilic substitution reaction. So I would just repeat for you: nitration, sulfonation, halogenation. In that we have taken chlorination and bromination. Fine, alkylation, and today we have taken acylation. So these are the 5 electrophilic substitution reaction. Please go through all the reactions repeatedly, so it will be very clear for you to understand. Fine, and then you prepare for your exams as well. Wish you all the very best. Take care and do study. Thank you.